Of all the technological advancements of our time, none feel as unpredictable as artificial intelligence.
Artificial intelligence.
Bottleneck heterogeneous models with the architecture. That's the kind of quite exciting and challenging problem we also try to solve.
Today, the average drug cost is almost 2.6 billion.
The performance is really important, but when you achieve this performance you need required, then what's the next important thing is your efficiency.
AI is awesome at what it's awesome at, but it kind of sucks at everything else.
We deployed AI systems across 60 manufacturing sites globally in Sanofi.
The even fundamental bottleneck of running AI we think is the energy.
How some of the smaller language models might become smaller and smaller and potentially embedded.
But why are we only looking at productivity? Why not also look at quality?
Thank you everyone for making it this Thursday evening. It's a weekday indeed. But you know what? There is no shortage of AI panels here in Boston or here around MIT, I know that. But what makes this panel exceptional and really unique is the mix, right? So in this room we've got enterprise engineering, frontier chips, mRNA strategy, and also real-world financial AI systems. So I think we're really in for a treat, and if scalable AI was the goal, then I think we have the Avengers here. And first we'll introduce ourselves, and I guess I'll go first. My name is Ree Lim, and I like to say I have 3 lives. So I was a financial reporter at CNBC Seoul. So that was my first life. Second life as an MIT co-founder for a startup focusing on 3D bioimaging. And then now I have my boss somewhere here, but I am a partner at One Way Ventures, where we back exceptional immigrant entrepreneurs.
If you have an opportunity to walk around a little bit and look out all the different directions, you can see out to the west, to the south over the river, where you've got, of course, MIT and BU. Of course, this new building. So you really can see pretty much all of Cambridge and beyond from right here. And so I really, to me, this is a very special place. And in fact, I've been here a long time because I was a graduate student in the early 90s at MIT. I did my PhD at MIT, just right over there. And with our founder, Tom Layton, who was one of my PhD advisors. And I joined Akamai in the summer of 1999. The company at the time was about 1 year old. And it's been pretty wild experience ever since. Now 26 and a half years, done lots of different things. I've run organizations, I've done engineering, architecture, all sorts of different interesting things here at Akamai. We've been changing throughout from CDN, static content, dynamic content, security, cybersecurity, now cloud computing, and of course, we recently announced our inference cloud with obviously a big focus now on supporting our customers with AI.
Thanks, Bobby. I'm Ashoka Madduri. I'm a global head of strategy and also intelligence at Sanofi at the mRNA Center of Excellence. So before joining Sanofi, I spent more than 10 years in biotech doing business development, corporate strategy. So during that time, I also did my MBA from MIT Sloan. That's why I met MIT community and Ree. I'm happy to really be here and discuss what we're doing at Sanofi, how we're scaling AI. So looking forward to it. Thank you.
Hi, my name is Chun. I am CEO and co-founder of FuriosaAI. Thank you for hosting this wonderful event, and it's a pleasure to be here. Actually, I started my semiconductor engineering career. My first job was actually here in Boston, actually. I worked AMD Boston as a co-op student, which was actually CPU design. It was like in 2006, actually. Then I worked a semiconductor company for almost 10 years. Then I started this FuriosaAI around 2017. So it has been almost like 9 years of a journey from as a venture-funded startup to develop this the high-performance AI chip. Hopefully we can share some of our perspective during this panel session. Thank you.
Hello, my name is Chun. Thank you for inviting me. I am head of AI Solutions Engineering Applications at Fidelity Investments and also an IT fellow. I've been there for about 16 years, and prior to that, I was chief architect of State Street Global Markets.
Today's session is really about sustainability. And I think sustainability can mean different things. It can be efficiency, it can be ethical deployment, or sometimes business viability, right? So I want to learn from the leaders of each industries. How are you looking at sustainability in terms of scalable AI? And what does that actually look like in practice today?
Well, yeah, it's a great question, and I really like the way the question was framed broadly, because oftentimes when people think scalability or efficiency, all the focus goes to the infrastructure layer. And that is super important, and I know we're going to hear more about that, because frankly, if you can't scale at the infrastructure level, the layers above aren't going to be able to scale either. So super important, but you do need to think about those layers above, from infrastructure to software to systems to processes, workflows, and ultimately up into entire organizations. And we've seen, I think again and again, studies have shown that enterprises are still struggling with the challenge of scaling AI in a way that really generates meaningful impact to the enterprise, real P&L impact. And given that, when I think about scalability and sustainability, I take a pretty broad holistic view, and I always start with matching the tool to the problem. And that sounds almost naive, but it's important, especially in the age of AI, because so often the hype around AI leads enterprises to start with AI as the goal, not value. So again and again, I hear companies saying, my goal is to use AI more. Okay, maybe, but how about start with the problem? Start with what is the problem that you're trying to solve that can really improve your products, your customer experience, your employee experience. What is the problem you're trying to solve, and then match the tool to the problem. AI is not always the right tool. And I want to say that again, because especially with agents, you keep hearing about agents being talked about as employees, part of your workflow. I don't like that. AI and agents also, they are tools. And you need to pick the right tool for the problem, and AI is not always the right tool. It often is, but it's not always the right tool. Sometimes I say that AI is awesome at what it's awesome at, but it kind of sucks at everything else. So use it for what it's awesome at, but not for the everything else. And let me just, one more thing on that, which is that also, when AI is the right tool, there's lots of flavors of AI. Another pitfall that I keep hearing is equating AI with large language model. There's a whole world of AI out there beyond large language models that can oftentimes solve your problem much better than a large language model, and potentially at 1/1000th, maybe 1/1,000,000th of the cost of what it would take to do it with an LLM. So pick the, and I should also add, even when an LLM is the right thing, you don't always have to use a gigantic ask me anything LLM. Right? You've probably heard about smaller language models. Instead of SLM being small language model, I like to say they are specialized language models. Because if you take a small model and specialize it, it can oftentimes do better than what the large model would do at, again, potentially 1/1000th of the cost. So match the tool to the problem. Don't just jump in and use AI everywhere.
Thanks, Bobby. I think one thing I'd like to talk about pharma point of view, right? So, I think you asked what is sustainable, right? I think what is not sustainable in pharma is the biggest issue is the drug development cost is going up and up. So it's almost 8 times more compared 30 years ago for each drug to come into clinic and also go to commercial. So, and today the average drug cost is almost 2.6 billion for the new drug actually to come into commercial stage actually. So it takes more than 10 years. Yes, we've seen the technology advancement, but we didn't really see the improvements actually in drugs to really come into market under cheaper cost actually. So I think connecting dots to what Bobby said actually, yes, at Sanofi we do think about actually fit for purpose actually, like what we're building for. So the 4 pillars actually we do use at Sanofi is, of course, publicly we communicated environmental impact by 2030 actually 55% reduction in emissions. and also by net zero by 2045 actually. So why AI come into picture actually? That's where we are using actually how to really draw the metrics actually to support this environmental promise that we made. And second pillar is actually operational efficiency. So we are really looking into manufacturing sites for easy to solve the problems actually. So we do have a real example. We deployed AI systems across 60 manufacturing sites globally in Sanofi, and we've seen almost to 80% of shortfalls actually. We prevented actually before even getting to the our hands actually. So I think that also saved money and also efficiency actually. So second thing is also about ethical deployment. I will get into maybe examples later actually in our discussion. So third one is ultimately we are in a business actually serving patients actually. So patient impact actually. So how to measure the metrics. So that's also we're looking into. So it's really the 4 pillars of sustainability. So we're looking into here.
I'll share more perspective from the compute side. So my analogy is it's like from transitioning from the gasoline car to, let's say, electric car. We think electric car is much more sustainable than the gasoline car, because the technology is fundamentally saving the more energy. I think we need the same kind of transition on this compute side as well. The GPU, the fundamental cost of running AI, these days even fundamental bottleneck of running AI, we think is the energy right now. So we need quite more innovation and breakthrough to make this AI compute more energy efficient. And when I say the energy efficient, it doesn't mean we sacrifice performance. Like electric car is not slower than the gasoline car, right? It's even faster. So we like to think about new engine to make this compute way more efficient. That's our kind of focus on this, making this, I think it's a very fundamental layer to make this AI ecosystem sustainable.
Sure. I would just like to say everything Bobby said was spot on. Same with Ashoka and Chun as well. I think on the one hand, a lot of us consumers that are on the other side, on the software side of compute, are looking forward to the cost curve going down, the efficiency curve going up. But I think one of the things that I'm noticing is this is a real opportunity for us to look at how we're actually doing things within the enterprise and within the business and within the processes that we have to make them more efficient, using tools that are kind of fit for purpose. And one thing that I've seen gain tremendous benefit from that is really how we're going from sort of the hype of the vibe coding that happened in the earlier part of this year to more spec-driven development. And then once that started happening, inspecting how our software development lifecycle is kind of strung together and trying to look at efficiencies there. But I agree with you, Bobby. I think a lot of the onus on large enterprises is really making sure that we're finding the right ROI value for the particular use case.
And AI models are only growing larger, and they're being distributed, right, as we speak. And Akamai has experience scaling globally, right? So from the lessons that you've learned, and of course everybody else in your respective industries, how can you apply those lessons to build scalable AI foundations?
Yeah, I do think that we're sort of at the beginning of potentially a repeat of something that happened about 27, 28 years ago, and that ultimately led to the invention of the CDN and the founding of Akamai. Backtracking to that time, some of you might remember, at that time, the World Wide Web was just taking off. And the inventor of the World Wide Web, Tim Berners-Lee, moves from, I think he was in Switzerland at CERN, but he moves here to MIT. And they established the World Wide Web Consortium, W3C, at MIT. And through, I think, accident or happenstance, they ended up on the 3rd floor of the building that hosted the Lab for Computer Science. The 3rd floor happened to be the theory floor, and that's where Tom Layton had his office and his students, in particular his graduate student, Danny Lewin. And Tim Berners-Lee was fretting over what was then called the World Wide Wait. The World Wide Web was getting congested. And the problem, and he knew this, the problem was that the web as it had been built so far, it was all self-hosting, and people were delivering websites that were getting very popular from a very small number of locations. And that was creating bottlenecks and congestion. That's what led to the World Wide Web. Fortunately, just down the hall on the 3rd floor, you had somebody who had all the tools, all the mathematical tools to solve the problem. That was Tom and Danny, and that's what led to the founding of Akamai. I think the same thing is about to happen, but with inference. As we've trained these models, now we have to use these models to do valuable things. And for all the caveats that I gave you earlier, as I said, LLMs are awesome at what they're awesome at, and they're actually awesome at a lot of things. And we are going to be seeing incredible amounts of incredible systems built with LLMs. But if we serve them the inference in the way that's currently being done, which is pretty centralized, we're going to end up in the equivalent of the World Wide Web. And here's a challenge for you. Help me out. I need an analog. So back then we called it the World Wide Web. So I need a catchy term. So here's the best I've come up with so far, and it's pretty bad. I've come up with large language mess, large language morass. I've come. A colleague said, "How about large language molasses?" So help me out here. If you can come up with something, I'll give you all due credit. We'll use it, but I'll give you all due credit. Yeah, so we need to find a way to deliver inference more efficiently, and I think distribution is going to play a role. Now, obviously, I'm saying that there's something somewhat self-serving here because that's what we do. But one of the reasons why we're investing in being an inference provider for AI is because we believe we have that capability to potentially solve the large language molasses that I think is coming. Molasses. It's the best I got so far. Help me out.
So yeah, I totally agree that the future of this AI inference should be much more distributed one. It doesn't have to be just a big LLM centralized place. I think small LLM and many different specialized models are working in orchestration to build the creative value will be the ultimate goal of the inferencing. I think this like a service area will have a huge innovation and transformation down the road, we believe. Especially as we go to more distributed area, those are also very power constrained as well. Power distribution, the power will be very important matters as well. So compute solution also needs to be quite aligned with those, be compatible with those kind of edge data centers. But from our perspective, another challenge is the compute solution not only efficient, but also needs to be quite programmable enough to support many heterogeneous models with the architecture. That's the kind of quite exciting and challenging problem we also try to solve, actually.
I actually think everything that Chun and Bobby said, absolutely agree with. But I also wonder how some of the smaller language models might become smaller and smaller and potentially embedded. In fact, earlier this year, there's a company called M5 Stack that builds embedded modules for $49 off of Alibaba.com. You can get a programmable module that has a Qwen 2 billion parameter model distilled from DeepSeek. And you can use that home automation. I think over time, we'll certainly have more distributed inferencing clouds and distributed architectures for inferencing, but I think some of these models are going to shrink and get a lot smaller as well.
Yeah, so I just add one line actually, said Sanofi, right? So what we are doing is also fit for purpose, as I said. So 3 different type of AI we are using now actually. So one is expert AI, where we use really LLMs, big LLMs actually to really look into new targets for drug discovery. And then other one is actually, Gen AI. So basically, very daily task actually for employees in the company. So the one most interesting one actually is snackable AI that we have in our app, in our phone. We can see the scenarios, what if scenarios actually, what's happening in the manufacturing side, what's happening in sales, That really computes actually over 1 billion data points actually. So I think, so using the models in the right way and the right purpose actually, that's where I think we see the meaningful use actually for solutions.
Yeah, snackable AI, huh? First time using it, hearing about it, but yeah. Pretty cool. And Chun, FuriosaAI, you've mentioned basically efficiency versus performance, right? It can't always be, I guess, a trade-off, but FuriosaAI is tackling the biggest AI bottleneck, which is compute, right? But it's not just about chip design, it's about energy use, data management, algorithm design, all of it, right? So how do we actually think about resource efficiency versus that high performance? Is this like a chicken and egg problem, or what's kind of the mental model here?
So as I said, like AI chip fundamentally must be very high performance machine. It's called sometimes we are accelerator. So so it's one of the ultimate kind of performance engineering we believe. So performance is really important. But when you achieve this performance you need required, then what's the next important thing is your efficiency. So how much power you are consuming, and what's the capex for your machines, and all those things are quite important metric actually we need to achieve. So I think the actually performance and efficiency is not kind of a trade-off relationship. Actually, we need to achieve both performance and efficiency as much as we can. But the trade-off, the challenging trade-off is actually this efficiency and also programmability actually, because the challenging part. So the AI chip design is quite different from designing this Bitcoin mining chip, because if you think about Bitcoin mining, the mining algorithm is actually a fixed algorithm. Actually, it's quite stable. It doesn't change that much. So you can optimize your chip to be very optimized for, let's say, the Bitcoin mining algorithm. So these days, all this Bitcoin mining is happening on the very specialized AG. But the difference between mining and the AI algorithms are one of the algorithms that evolve very fast, that changes, one of the fastest changing algorithm we have ever seen in terms of scale, in terms of its kind of architecture. Meaning that AI chip needs quite fundamental general architecture to support very changing workload. So it means it needs somewhat flexibility. At the same time, you like to achieve quite the efficiency as well. So finding the right trade-off of this efficiency and flexibility is one of the quite the challenging part of AI chip design, which actually we are very excited about, actually.
Anyone want to chime in on the scalable AI efficiency versus performance angle? No?
I just want to say thank you for making it faster and cheaper.
All right. Well, I guess the next question is to Ashoka and Chun, because you guys are in industries where trust is paramount, right? Like healthcare and finance, right? So how do you scale AI while ensuring that you protect trust and privacy and still deliver on the real world impact? Seems like that's a pretty big mission.
So I think we're in patient serving industry, right? So all the components you mentioned is crucial for us actually to develop a drug that is successful actually to reach the patient. So I think one of the philosophy that we are using in the company is RAISE. Basically, it's responsible AI at Sanofi for everyone. So that goes through so much scrutiny and of a risk that we're actually taking actually with these systems actually. So there is a guardrails we put together actually in the process. So I think total we pushed more than 50 actually AI systems through this process actually, both our internal processes and also working with the developers actually outside. So I think that is really crucial actually, to really, especially dealing with the data from the patients, and also there's a lot of data coming from outside, historical data actually. So I think this is something actually, the ethical point of ethical deployment. This is really crucial for us actually while building our drugs actually. So.
Yep, Ashoka and I were talking earlier. I think our industries have very similar problems, similar solutions in terms of guardrails and whatnot. One of the things that comes to mind specifically in this area is, and I've talked to lots of peers and other companies as well, is that we have to find the right balance between approaching AI governance in a way that is not technology governance, because technology governance in large enterprises tends to be very bureaucratic and so at the same time, we still have to let all the innovation flow, because there's so much excitement and energy down to the individual developer, to UXD, user experience designers using Figma Make to generate interactive prototypes, for example, to other functions as well. So I think that's part of the challenge where you would find the sweet spot to be able to figure out a way to have the same kind of mechanisms for safety and whatnot and technology management that you would do in typical technology governance, but kind of speed up the learning loop and speed up the iteration rate so that you can still let the innovation kind of flow and bubble up.
Yeah. So I just add one more thing, right? So I think the philosophy also is like AI, advise, human decide. Basically, another mantra that we also use is basically AI plus human. Basically, that is the one actually making a. Human is the one making decision actually, so more responsible, taking accountability for the human actually. So that is also very important actually, when it comes to ethics. So.
Moving on to the next question, so I want to rethink about scaling, right? Because I think when we think about scaling AI, it's always about maybe the parameters, the model parameters and the size, right? But maybe there's something else here, like maybe there's fairness, long-term resilience, and these in some ways abstract things that we don't think about quite as often. So do we have any thoughts on that?
Yeah, well, when it comes to measuring, there's a huge challenge here, in that sort of on one extreme, all the way down sort of at the software infrastructure layer, it's fairly easy to measure, say, cost per token or watts per token or something like that. At the other end, at the enterprise level, it's not hard to measure something like, profit and loss. We have to do that. It's in the middle. Like when we look at, say, a developer using an AI tool, has it improved? What's the impact? And how does that, impact on the company's bottom line? But the measurement, so the measurement is very difficult in the middle. And one challenge that I always point out is that almost all the effort that I've seen where people are trying to put in place metrics to measure this stuff, it always goes down to productivity. And productivity is hard to measure, especially like a developer or something like that. But why are we only looking at productivity? Why not also look at quality? This bothers me a lot, that everybody talks about AI as a productivity improver, and therefore they talk about how many people we can eliminate from the job force. How annoying is that, right? How about talking about how much it can improve the work that that people do and make the people more valuable? Make the ROI on the people better because they're able to do better work. You never hear that. And I admit it's really hard to measure this stuff, but it's also hard to measure the productivity part of it. Anyway, so my plea is simply, as we work on metrics, let's not focus just on productivity, let's focus on quality.
So I can add from pharma again point of view, right? I think our metric that we aim for is patient impact for a compute unit. That is something very complex to measure actually, but we do have measurements actually. For example, right? We're combining both the digital twins, like basically virtual patient, with the AI systems. We are able to actually develop the drugs much faster actually. So using digital twins, actually we have 3 examples that we shared publicly. One of them is when there is a drug approved in adults, how we can really interpret actually, make a model actually that can work in a pediatric population actually. So that you can avoid actually large number of clinical trials, patients in controls actually when they're not getting medicine, right, a placebo. That is one of the clear example actually. And also through digital twins and AI systems, we also seen actually how the approved drug can be applied to new disease, new indications actually, before even getting into clinical trial actually. So I think these are the clear examples actually where you can look into to really reduce the cost for drug development and also improve the patient's lives actually. So I think yes, there is a lot of metrics actually, but if you have clearly measuring actually what the impact looks like before AI implement or after AI implement, you can really see a change actually.
Sure. The thought that comes to mind is around coding agents. That's been on my brain a lot lately, to be honest with you. And I agree with what Bobby said. You have to take into quality as well. And some of the analogies that I've used at work has been, you can take the Iron Man suit and you can give it to Tony Stark, or you could give it to Homer Simpson, and you're going to have two different outcomes. And what I mean by that is senior engineers, coding agents are like, they just give them superpowers. You can do so much. But a lot of the thinking and discussions that we're having across my peer group is how do we use, with spec-driven development, how do we kind of ensure that the prompts to the coding agents do local linting, local code, static code quality checks. There was a paper published, I think a week ago or last week, from Carnegie Mellon, and I think they scanned about 800 or so GitHub repositories into two different buckets, one that did use coding agents and one that did not. And what they found was that you immediately get an uptick in productivity, which is basically lines of code committed, but then you immediately follows with an uptick in static code quality warnings and lines of code kind of exploding. So I think the quality comment that you made, Bobby, is spot on. We have to be able to use these tools very efficiently.
But I think we think about the kind of the AI race or war, right, globally, where people think, oh, China is gonna take over the AI race, right? The US gonna move fast, and Korea saying, we're gonna be number 3 now, right? But how do we think about collaboration across actually countries and also across research, industry, and policy? What's maybe blue ocean or a North Star with that regards for cross-border collaboration for scalable AI to make it sustainable and fair and equitable?
I mean, it's an area that I'm not much of an expert on policy, but let me just offer one quick thought just personally. Most of my life, I feel like has been characterized, at least when it comes to the question you're asking, by increased international cooperation. There's been more and more free trade in terms of ideas, but also commerce. And the last few years, of course, are characterized, at least certainly at the federal level, by the opposite. And frankly, to me, it's bewildering. Maybe that's all I got to say. I'm bewildered, and I don't know that I can offer much else.
Good bewilderment, or?
No, bad bewildered.
Okay, so brace ourselves.
Well, hopefully we can reverse it.
One thing, guys, I think hybrid approach is the best approach. You can do in a company certain things. You can really always collaborate. Borrow the thing that you can't really build inside. So we did actually multiple collaborations with OpenAI and also Formation Bio for different kind of for technology to drug discovery. So coming back to policies, right? We also working with the FDA, AMA in Europe actually to really understand actually the AI systems we're implementing for drug discovery, making sure that actually they also see the same way that we are seeing actually. Because as you can see, going from Europe to US and Asia, right? Every agency sees things very differently actually. So making sure that there is a harmony and standardization actually. So I think really the global collaboration is really important actually. So the drug approved in US should work same way in Europe and everywhere else in the world actually. So I think AI system, same thing actually. It's the same drug, same systems actually. So, but we want to make sure that these policymakers actually understand the same thing actually. So they speak the same language. Yep.
I think as you notice, a lot of countries are talking about sovereign AI these days. They like to kind of cultivate and their own AI capability and also control their technology as much as they can. But in reality, actually, other than US, I guess, other than US and China, I would say it's not easy to build the entire things sometimes by themselves. So I think the collaboration, global collaboration, those countries who don't want to rely just on just a single company or a single nation, can potentially collaborate with each other to build their own sovereign AI concept, I believe.
One thought that I had is I personally have never witnessed or experienced so much energy from public and private and academia in open source. You know, open sourcing code, open sourcing model weights. I love that OpenAI open source GPT OSS, for example. It's just, I think that's a great solution because there's so much human energy, you know, from all various levels, just focused on the things, I guess what you said, Bobby, the things that LLMs and Gen AI, for example, do very well. It feels very, very magical because the sophistication of the language that's output is very high, so.
Just at one point, actually, talking about collaborations, right? So also, it's very unconventional, actually. So we partnered with Formula One McLaren to really understand their thinking, actually, about efficiency. As you can imagine, actually, pit stop, their record is actually 1.80 seconds. So the reason we collaborated actually with this company, right, to really understand what goes through it, actually, to reach that really milliseconds precision, actually, the time savings, right? So we're building that kind of a philosophy actually in the company actually through AI systems actually, especially to start our manufacturing. We've seen some efficiency improves actually. So even you see these collaborations actually to really understand what they're doing and borrow some of the thinking actually to our industry side.
So Bobby, the world is not doomed. Seems like there's a lot of, silver linings. My last question, and we'll open up the floor, but it's rapid fire style, so 30 seconds each. So if you could come up with a global metric to measure sustainable AI, what would that be?
Happiness per inference.
And I think everyone using ROAI, return on investment of AI investments. I think if you go one layer deeper, right, for our industry, especially the industry we are in pharma, patient impact for a compute unit actually. It's so complex, that's a North Star we are aiming for.
Health per inference.
Yeah, for sure. So that I think it's complex, but I think if you keep this as a North Star, right, you can aim for it actually. Can you deploy your AI in different verticals as you combine actually, you see the impact. So
I'll say the intelligence per energy, or we can say value per energy. I think how much value we can create per value kind of relate to the quality as well. I think the value per energy can be the metric for sustainability.
I would say something a little bit different. I think it's just the overall STEM literacy in youth. And I loved, Bobby, that you mentioned that your wife leads Day in AI, for example, because I kind of fear that before, if you were lucky, you had access to a computer in the classroom back in the 80s if you're a Gen Xer. Most of you look like you're a lot younger than I am, but then it was access to content in the World Wide Web. Now it's kind of access to intelligence and reasoning, and I really think, especially in economically disadvantaged populations, we really need to increase literacy in STEM.
Well, thank you very much for all your questions.